Here's one more example of using a three-set Venn diagram to organize data involving three qualities of people. So we have the data that was gathered in a survey. Here, 30 people are married, 40 people own a car, 20 people own a house, 15 people are married and own a car, 18 people own a car and a house, 5 people are married and own a house, 2 people are married, own a house and own a car, and 14 people said they're not married and don't own either a house or a car. So we've got these three things that are mentioned. We've got the fact that someone might be married, someone might own a car, and someone might own a house. So we've got three sets that we can put into our picture, and we know we have overlap amongst them. But let's start by drawing those three sets. I'm going to make two high, overlapping, and then one lower. So I'm going to just label them married, owning a car, so I'll just put car for owning a car, and owning a house. Put house for owning a house. All right, now in our last example, we had the word only after these first three pieces of information related to how many people were in a particular category. This time we don't. It says 30 people are married. It doesn't say married but don't own a car, don't own a house. There's no only there. So that means that those 30 people are all of the people in the entire married circle. And there are actually 4 regions in the married circle. You've got the people who are married only without owning a car or a house. You've got the people who are married and own a car. You've got the people who are married that own a house, and you've got the people who are married, own a car, and a house. So there are 4 numbers there that we need to break 30 into. And right now, with just the information of 30 people are married, we can't separate that. So we need to break this into 4 numbers. To do that, we're going to need to look a little further in the information. So same thing could be said for 40 people own a car, 20 people own a house. In fact, sometimes it's best to go all the way down the list to where you get the most specific information. And when we look all the way down through the list, these last 2 actually happen to be the most specific because this says 2 people are married, own a house, and own a car. So what that's telling me is that I have 2 people who are in the intersection of all 3 sets. So let me give myself some room here, put that information in. So I've got 2 people that are right at the intersection of everybody, right in the center. And then the last piece of information is also very specific. 14 people said they're not married, don't own either a house or a car. So those 14 people would be in neither of these sets. They would be totally on the outside. 14 people on the outside of the entire circle. All right, so sometimes it pays to start at the most detailed, and then we're going to work our way back up to the least detailed, which was 30 people are married. So let's work our way back up. Let's start with 5 people are married and own a house. So if 5 people are married and own a house, that means that they are in the overlap between being married and owning a house. So that overlap would be right here. And there's got to be 5 people in that shaded region. Those 5 people who are married and own a house, 2 of them are married, own a house, and have a car. So what would be left would be 3 people to go into the region where we have married and owning a house but not owning a car. So together now, 3 and 2 make 5, and that satisfies this condition of 5 people are married and own a house. So we're teasing apart the 5 to get the 3 and the 2. All right, let's keep moving up and do the same thing. Now we have the next line up says 8 people own a car and a house. So that would be 8 people owning a car and a house would be here. We already know 2 people are in the overlap of all 3 sets. So if there's got to be 8 people owning the car and the house, we need 6 more to make the 2 along with the 6 total up to 8. So 2 plus 6 gives us 8 people owning both a car and a house. So we continue to use this information and tease apart the data. Next one up, we have 15 people who are married and own a car. So once again, I'll highlight that. If we're married and own a car, we're in this region. Once again, we know 2 people are married, own a car, and have a house. Sorry. So 15 minus 2 means 13 people are married and own a car. So, but not a house. So now we have 13 plus 2 is 15, so that satisfies that condition. And so as you can see, we've slowly taken care of all of this information about the details of the little pieces where we have overlap. Now we can actually get to taking these big numbers of the 30, 40, and 20, the people who are in the total number of people who are in each set, and break that up to figure out how many people are married only, have a car only, have a house only. So we can start with married as an example. If 30 people are married, that entire circle has to be 30. So if I know that part of it is 13, part of it is 2, and part of it is 3, what's left for the part we don't know would be subtracting those values from 30. So 30 minus 13 is 17, minus 2 is 15, minus 3 is 12. So we have 12 people in this region of married only. Okay. And then I'll erase that just to give myself a little more room. We can do the same thing for 40. 40 people own a car. That means this car circle must total to 40. So if I know that part of it is 13, 2, and 6, I can work out what's left in the car only region by subtracting 13, 2, and 6 from 40. 40 minus 13 is 27, minus 2 is 25, minus 6 is 19. Now, of course, you could do that with a calculator instead of in your head. That's your choice. I'm just doing it quickly here. And finally, 20 people own a house, so we can fill in the final house-only region. If this house total has to be 20, 20 minus 3 would be 17, minus 2 is 15, minus 6 is 9. So we should have 9 people who own a house but are not married and do not own a car. So there we have it. We've got all of the pieces accounted for now in our diagram. And every region has a number, so we should have everyone who was involved in the survey. Which leads us into the next question. How many people were surveyed? Just add up the entire circle. 12 plus 3 plus 2 plus 13. You can add them up in any order you want. 6 plus 19 plus 9 plus 14. Adding them up in any order you want, we can actually get our total of 78. 78 people were involved in this survey and asked whether they were married, owned a car, or owned a house. Question 2, how many people own a car but not a house? All right, this one I'll highlight just to really emphasize it. If we own a car but not a house, that would be like looking at the car circle, but then eliminating the house numbers. So if I eliminate the house numbers, that would be eliminating the 2 and the 6. So I'd be eliminating the house numbers involved with that. So that leaves me just the 13 and the 9. And 13 plus 9, or sorry, 19, 13 plus 19 would be 32. 30 people own a car, but not a house. Sometimes it's very helpful to kind of cover parts up. That's what I'm doing when I cross things out, is I'm covering up the part that we do not want to allow, the not the house. All right, so to make the next question easier to see, I'll erase my marks for that. Question 3, how many people are married and own neither a house nor a car? So we want to look at married folks. So I'll highlight the married folks. But we want to eliminate the people who do not who do not own a house and do not have a car. So they own neither of those things. So I'm going to eliminate the car and the house. So that means I have 12 people left. So 12 people would be the answer to question 3. So Venn diagrams are a good way to organize information and then more easily answer questions about different parts of that situation. And we use logic to kind of organize and then answer those questions.